Good morning, Townview. Let's go ahead and get started. Today we're going to be talking about average atomic mass. So let's move on. And you don't need to write this. I'll tell you what you need to write. This isn't really important to be written down. So small atomic masses are measured in atomic mass units, AMUs. So anytime you see AMU, know that means atomic mass unit. I think we wrote it in our last notes, so it's not something you need to write down. An atom of carbon-12 was assigned the exact mass of 12 AMU. All other atomic masses are relative to carbon-12, which means carbon-12 was assigned the mass of 12 AMU, which is equivalent to 12 grams, and all other atoms are just relative to carbon. So carbon's real important with average atomic mass. An atom that's twice as heavy is going to have 24 AMU. An atom that's half as heavy is going to have 6 AMU. So that's what we mean by relative. So hydrogen has, what's the mass of hydrogen? I don't want y'all to answer. It's going to be 1/12 the mass of carbon-12. Let's go ahead and move on. All right, so almost all elements occur as a mixture of isotopes. The percentage of each isotope is constant. Hydrogen is composed of 3 isotopes. These are the isotopes of hydrogen. You don't ever need to learn the isotopes. That's not something y'all need to do here. But H1, which is regular hydrogen, that makes up 99.99% of all hydrogen. So that's what a majority of it is. Hydrogen 2, that's a very, very small amount. And then H3, even smaller amount. This one's extremely unstable. You're not going to find very much of it. So listed on the periodic table, you see the average atomic mass. The average atomic mass is going to be the average of all the isotopes multiplied by its percent abundance, which means how much of it actually exists. The atomic mass is not a whole number. It's never going to be a whole number. It's impossible to make it a whole number unless we round, which we're going to round pretty frequently. Percent abundance of the isotope is going to be given to you in most equations. Sometimes you have to calculate it, but for the types of problems we're going to be solving, this is going to be a given information. The mass of each isotope, that's going to be given as well. Unless if they just tell you that you're dealing with fluorine, like regular fluorine, that's going to have a mass of 19 because that's what the periodic table says. So this is the equation I want everyone to write right now. So mass of isotope 1 times the percentage abundance divided by 100. That's one part of the equation. And then you add the mass of isotope 2 times its percent abundance divided by 100. And then it says plus ... which means this depends on how many isotopes exist. I just told you guys hydrogen has 3 isotopes. So if it's got 3 isotopes, how many times are we going to repeat this part of the equation? All right, 3 times. Good. So this is just a trivia type stuff. What element has the most isotopes? It's going to be cesium and xenon. So they have 36 isotopes each. So if you were to try to solve this equation for cesium or xenon, you're going to have this part of the equation is going to repeat 36 times. So only thing I want you to write from this page is going to be what you see down here, this equation. I'm trying to erase, but it's not letting me. All right, so the only thing I want you to write is this part of the equation. Include the plus ... just to remind you that this equation will go on and on depending on how many isotopes exist. That's going to be it. That's all the time you get to write those down. Let's go ahead and move on. So this is our first practice problem. I can read it for you, but it's not. Well, actually, I'll go ahead and read it. Calculate the average atomic mass of sulfur if 95% of all sulfur atoms have a mass of 31.972 AMU and 0.76% have 32.971 AMU, and then 4.22% have a mass of 33.967. So this is where I messed up with yesterday's classes. I had them count the significant figures in the percentages, which is just not the good way to do it. So right here we have 3 significant figures. Right here we have 2. Right here we have 4. And I made them put their answer in 2 significant figures, which is what you would typically do when you're dealing with significant figures. But the way we decided to do it in the chemistry department is we're going to count just this part right here. So our mass has 5 significant figures. This one has 5 significant figures. This one has 5 significant figures. So in the end, our answer should have 5 significant figures. So we're not going to look at the significant figures and the percentages. So let's go ahead and write out our equation. So isotope 1 is going to be 31.972. And then in parentheses, we'll put our percentage, which is 95%. Close parentheses, divide by 100, plus our next isotope, which is 32.971. And then in parentheses, we're going to put 0.76, close parentheses, divide by 100. And then our third isotope, which is 33.967. And then their percentage is going to be 4.22. Close parentheses, divide by 100. So our next step, this is where we grab our calculators. There is a way to plug this into the calculator as a single equation. I don't suggest doing it that way because it's just easier to do it in 3 separate parts. So what we're going to do in our calculators is first thing we're going to do, we're going to multiply these 2 numbers, and then we're going to divide by 100, and then we'll write our number up here. So let's go ahead and do that real quick. So 31.972 times 95, divide by 100. You should have got 30.373, and then plus, and then we move on to the next one. So 32.971 times 0.76, divide by 100, and that gives us 0.25057. Bring our plus, and it's going to be 33.967 times 4.22, divide by 100, and that should have gave you 1.4334. And then our last step is just going to be to add those 3 numbers. So plus 30.373 plus 0.25057. What I came up with was 32.057, and I rounded because we got rid of the numbers that came after that. And then to check our work, we're just going to look at the periodic table, and we're going to find sulfur. So sulfur is number 16, and you can see that the calculator or the periodic table says that it's 32.066, which means we're close enough. So our answer is going to say S is equal to 32.057, and then the unit for these is always going to be AMU. Put your answer in a square, and this is what I want to see for all of these problems. So I want to see the work look like this, and I want your answer boxed up. I want you to make sure that you include what element it is, makes it easier for me to check. And also make sure to include units. So we always use units in chemistry. Any questions about how we did that? All right, let's move on to the next one. So here we have Cu, that's copper. And what you're going to see is every arrangement, every way we can ask you the same type of question. So all the questions we're about to work on are basically the same thing. They're just asked in different ways. So the mass of copper 63 is 62.94 AMU, and the abundance of copper 63 is 97.17. So I'll just go ahead and put that right here. I said 97, I meant 69.17. So let's go ahead and write out our equation. So it's going to be 62.94, and then our percentage is going to be 69.17. Close parentheses, divide by 100. And then copper 65 has a mass of 64.93. And then our percentage is going to be 30.83. So one thing that you probably recognized is all the isotopes should equal up 100%. So 69.17 plus 30.83, these two numbers together, they need to equal 100. If they don't equal 100, that means you're either missing an isotope or you plugged in the number incorrectly. That's just something to know moving forward. So go ahead and solve this one on your own. Once you're finished, we'll go ahead and move on to the next one. All right, so I'm gonna plug this into my calculator. So 62.94 times 69.17 divide by 100. This gave me 43.55 because you round away, or not 5, this should be a 4, my bad. And then 64.93 times 30.83 divide by 100. This should be 20.01 or 0.02. And then we just add these numbers together. So plus 43.54. You should have got 63.56. If you got 0.55, that's perfectly acceptable. So your answer should say Cu is equal to 63.56 AMU. And then we box it up. And then we move on to the next one. All right, so this one I want you to try doing completely on your own. So we solved this one on the board, but for those of you who are not here, the answer you should have come up with is CR is equal to 51.99 AMU. Let's go ahead and get this next one. I'm gonna give you a few minutes to work on your own. All right, so for this one, we have iron 55. If they don't give us a particular mass in AMU, we're just gonna plug in 55. That's gonna be our atomic mass. So 55, and then in parentheses, we put in our 15, divide by 100, plus 56, and then 85, 100, and then in the calculator, 55 times 15 divide by 100. That should have gave you 82.5. Nope, it should give you 8.25. Plus 56 times 85 divide by 100. That should have gave you 47.6. We add these together. And that gives us 130, no. I added 82.5. That should have gave you 55.85 AMU, and this is for Fe, which is iron. Is this what we all got? All right, let's move on to the next one. All right, so for those of you at home, let's go ahead and solve this one real quick. So we got chlorine 35, which is 34.969, and then our percentage of that is going to be 75.8, and then we're going to add to that 36.996, and then our percentage for that. So if half of our chlorine atoms are 75.8, the other half we're going to have to do 100 minus 75.8, which leaves us with 24.2. And then after you plug these into a calculator, you should get 35.459 or something around here. So chlorine is equal to this in AMU. Let's go ahead and move on to the last problem. Let's go ahead and get this one. This is our last one, and then you get to work on your assignment. So for our last one, we have 10, oops. For our last one, we have 10 AMU times 20% plus 11 AMU times 80% divided by 100. So 10 times 20 divided by 100 should have gave you 2. 11 times 80 divided by 100 should have gave you 8.8. And this is going to equal 10.8. And that's, if you look at your periodic table, that's going to be boron. And that's it. We're done. Go ahead and work on that assignment. Be sure to turn in before you leave class today. And good luck.